Hello.
Hello.
Hello there. Oh, some of you have already figured out how to use chat relay.
That's fantastic. We're going to remind you multiple times how to use chat relay, but it seems like some people have been here before.
Yes. Um, it's Dr. Let's just start by explaining how the chat relay works. Oh yeah, a lot of people have figured it out. If you want your message to appear here, you can use the Zoom chat and send a direct message to chat relay, which is one of the co-hosts. Do not send it to me or Leo. We can't actually read them. So that will not end well because we will not see your message. But yeah, send a direct message to chat relay and then it will appear right here in the chat, right here. Yes, it is just like Twitch and that stuff. Yeah. So and we would like to introduce the Math Kangaroo representative today, Dr. Van Koroleva, who is the Connecticut State Director. I mean, that's like one of the 50 states, so like, she's pretty high up there.
Yep.
Dr. Koroleva, would you like to share some words with us?
Hi everyone and happy 2026. Today is the first Sunday of the new year and school hasn't even resumed yet and we are already gathering together to solve math kangaroo problems. So I think that's pretty awesome. I hope you join millions of students worldwide for the competition in March. Registration is still open until February 1st. And now, apart from this traditional individual competition, I'm excited to announce that Math Kangaroo, we also have a team competition. In fact, in November 2025, we have the pilot team competition, and it was a big success. There were 500 teams from all across the grades. Each team consists of 2 to 4 students. The students and the coaches love it. So find a friend or two, form a study group, practice regularly, have each other grow, and come back to us in the fall for the team competition. I'm so glad you joined the live show session today. I think that studying math sometimes may feel lonely and difficult, but don't give up. You can ask for help from friends, from parents, teachers, read books and other resources that help you understand the concepts and practice regularly. And I think it's very important to find a community of like-minded people like LiveSolve because studying together makes it more fun and keeps you motivated. And I also believe that solving creative math problems like the ones you find in Math Kangaroo will really help you enhance your problem solving skills. So thank you, LiveSolve again, and happy studying.
Yes. Thank you, Director Koroleva. And another person I'd like to introduce is my co-teacher today, Joe. And okay, so Joe is a junior from Maryland and has been doing competitive math since elementary school. He's qualified for Amy 3 times and enjoys competing in both math and physics Olympiads. He is also the tournament chair for his Mu Alpha Theta chapter and the captain of the school math team. Outside of this, he enjoys varsity tennis, playing the cello, building fun contraptions, and engaging in turn based strategy games. Give a warm welcome to Joe.
Hello, everyone. Um, I am also pleased to introduce my fellow co-host, Leo Ellison. Leo is a high school junior in Seattle, and he does AMC yearly and achieved DHR in 7th grade, and he has qualified for Amy since 9th grade. He got second at his local UW Math Hour Olympiad twice, and besides math, he plays on his high school's frisbee team and coaches the middle school team. He is also the captain of his school's quiz bowl team and specializes in history questions. He enjoys biking Seattle streets and paths, as well as folding modular origami. So a warm welcome to Leo as well. Yes. And with that, I think we can get to what you've all been waiting for. Right? The math kangaroo problems. All right. What do you say we get started, Leo?
Let's do it. And I can read out the first question. Okay. Emily wants to enter a number into each cell of the triangular table right here. The sum of the numbers in any 2 cells with a common edge must be the same. She has already entered 2 numbers. What is the sum of all the numbers in the table?
Well, we're not starting with all that much information here. And so, I think, in general, for these problems, where you need to find something that you don't necessarily already know, it helps to set a variable. What do you think, Leo?
I think we should set up x. X is a great variable. Okay, where should we put x? We could put it like, we could put it here. I think this makes sense. It's pretty near the action, near the other numbers. That would make it valuable for this problem. What do you think?
Yeah, I think it's a good place to put it so we can get some useful information out of it. Let's see. Now that we have x, we can get some other information out of it. We see that it says 2 cells with a common edge must have the same sum. So, let's see. These 2 add up to x plus 3. But there's more than one grouping of these 2 edges. We could also group these 2 edges.
Right.
And so, with that information, what do you all think should be in this box that I've marked with a question mark? Yeah, put your ideas into the chat. Yeah.
Okay, I'm seeing some 3s, and that's what I was thinking also. Because the sum of any two cells that share an edge has to be x plus 3, and we already have an x, this one's got to be 3. So the sum, I can write that as x plus 3. Or maybe we can do even better than that, actually. Maybe we can figure out what the sum is right now. What do you think, Joe?
Yeah. I mean, there's other edges to look at. And one very appealing edge seems to be the one right in the bottom left corner. We have a 2, and we have a 3. What do you think that implies, Leo?
Well, it means that the sum of any 2 adjacent cells has to be 5, because 2 plus 3 equals 5. So now that we've got the sum equals 5, we can fill in the rest of this table pretty easily. So this x here, it's got to be 2, because it shares an edge with a 3. And how about this cell I've got at the top of this triangle, right up here? What does that have to be?
Yeah. Put your ideas in the chat. What do you think should be in this cell at the top?
I'm seeing a lot of 2s. Okay, fantastic. Yes, that should be a 2 as well.
Yeah.
Actually, anything adjacent to a 3 has to be a 2.
Yeah. We can fill out. And because we know anything adjacent to a 3 must be a 2, we also know that anything adjacent to a 2 also must be a 3. So we can actually use this information to fill out even more boxes. Or triangles, I suppose, in this case. Triangular boxes. Yes. So now that we have all of these filled out, all that's left is to add them. So let's see, let's count them. 1, 2, 3, 4, 5, 6. We have 6 triangles with 2 in them, times 2. And then we have 1, 2, 3, 3 triangles and 3 with them. So what do you all in the chat think that the answer should be?
All right, I'm seeing 21. Right, because 6 times 2 is 12, 3 times 3 is 9. Together it's 21, so our answer should be answer choice C, 21. All right, should we take a look at the answer?
Yeah. I think it's a good time to look at the answer. Let's see. Ooh.
Here it is. Okay, we got it correct.
All right. Excellent job, everyone in the chat.
Doing well so far.
Oh, yeah. Let's move on to the next problem. I can do the honors of reading it this time.
Thanks.
The faces of a cube are painted black, white, or gray, so that opposite faces are of a different color. Which of the following is not a possible net of the cube? Oh, this is an interesting question. Where do you think we should start with this, Leo?
Well, first a little disclaimer. On my screen it's showing up, the black is showing up as bluish, and on Joe's I think the black will show up as transparent.
Oh,
but
yeah.
The most important part is that opposite faces are not the same color. I think
Yes.
we should. I think we should look for any. I think we should just be looking for nets that have opposite faces that are the same color, and then we know that's got to be it, right?
Yeah. Hmm. Let's see. Let's start with which one do you think we should start with, Leo?
I guess A. A is a good place to start always.
All right. So let's see. A net is when we fold this shape, we can make a cube. A net is an unfolded cube. So when we try to fold this one, let me like draw a cube right here so I can better represent where the faces are. Okay, so dotted lines are the ones in the background. So let's put this face, it doesn't really matter where we put it because it's all about the relative position. Let's put the black one on top. And we know that next to it, we have a white face. And we know that next to the white face, we have two gray faces. But where should we put these gray faces, Leo? It seems like we need to think a bit more to construct this cube.
Hmm. Well, what I thought of is we can kind of already, just by looking at the net, even though we don't know exactly how it's going to be oriented, we can see which ones are going to be opposite each other. So I've drawn, I've drawn this cell, the one I have in yellow right now, has outline in blue, and same with this one right here. Because if you imagine you're like an ant walking on a cube, and you're on the bottom side, and you walk forward, and then you walk up the side of it, and then you walk like you've gotten to the other side. That's the only way you can get to the other side, by going all the way through a whole face. So in that way, we can see that these blue ones have to be opposite each other, and the same thing were these purple ones. And the other two remaining ones, which I'll put in green, are also going to be opposite each other. And then we can check whether this one is going to be a problem. And it looks like no. Well, actually, we can show that no, because the ones that are opposite each other are of different colors. So this one is a possible net of this cube.
Mhm. Yeah. So we know it's not A. Let's move on with another cube. Let's go with I think we should go in order. What do you think, Leo?
Sounds good.
Yeah. Let's look at B next. And let's see for B. Well, we can apply what Leo just said again, where we have these four, and when you're wrapping these all into a cube, you have to wrap them like around each other. So like if you had glue and you were putting this together, you would take this edge and you would be gluing it to this edge because it all loops together to make like a closed shape. And so we have these two are opposite each other. The two I've highlighted in what is this color? Teal?
Yeah, something like
Um,
that.
yeah, teal. These two are opposite each other. And finally, the ones that let's see, I'm running out of colors here. These two are opposite to each other. And we can also, just like A, see if this one will be a problem. Well, we see that the teal ones are different, the two yellow ones are different, and the two red ones are also different. So it can't be B either. Would you like to do the honors for C?
Yeah, I got you. So this one that I'm going to highlight, or that I'm going to box in blue, and this other one are opposite. So far, so good. We've got some more in purple. Also, so far, so good. And some more that I'm going to put in this like light green color. And those are also okay. So it's not going to be C either. And can you do D?
Yeah, I would be delighted to. So we're going to use this exact same algorithm, the same pattern. You know, pattern recognition is really an important skill in competition math, you know? Speaking from personal experience, like if you can see a pattern, like it's like you're almost there. Like patterns are very important, you know? That's one of the things the human brain is best at, recognizing patterns. And as you can see with these boxes that I've drawn while I was giving that whole talk on pattern recognition, you can also see that the boxes of the same color are, well, not the same inside color. So the two reds aren't the same, the two greens aren't the same, and the two purples aren't the same color. So it can't be D.
All right.
I mean,
Yeah.
we've eliminated all the options, so we know it must be E. But I think we should still go through with our method to see how it works.
Yeah, good idea. Okay, I'm gonna box them up. Okay, these blue ones I don't have a problem. Let's look at the top and bottom one though. I see some black squares on the top and the bottom. Let's look at those. It looks like the ones I've boxed in green actually do have a problem because they are the same color and they are opposite each other. So that means the answer has to be E, right?
Yeah, that seems about right. And the chat has been like, yeah, I've seen the chat. The chat has been saying E this entire time, and you know what? I think I agree with them. What do you think, Leo?
Yeah, I think they're ready to see the answer.
Yeah. And the moment of truth. It's E.
Yeah. Okay. Good job so far, chat.
Excellent job, chat. Okay. Do you think we're ready to move on to the next one? Oops.
Yes, I think we are. Oh wow, this one's a long question.
A lot of reading.
Yeah.
Would you like to do the honors?
Yeah. 4 ladybugs sit on different cells of a 4x4 grid. One of them is sleeping and does not move. Each time you whistle, the other 3 ladybugs move to a free neighboring cell. They can move up, down, right, or left, but they are not allowed to go back to the cell they just came from. Which of the following images might show the result after the 4th whistle? Okay, I think step 1 for this problem should be figure out which ladybug is sleeping. And this one shouldn't be super hard.
Yeah.
So, just looking through the whole, like, the progression through time as we go from whistle to whistle, which one seems like it's sleeping and it just isn't moving?
I've labeled these ladybugs A, B, C, and D, so you guys can put in the chat which ladybug you think isn't moving. Yeah. I'm not sure if you guys can see it super clearly, but this one is A, this one is B, this one is C, and this one is D.
All right, chat's paying attention. They said the answer is C.
Yeah.
And yeah, I agree with that. It looks like C's just staying there the whole time, just chilling. Okay. C is sleeping.
Yeah.
So maybe we can even eliminate an answer choice for this. What do you think, Joe? Are there any answers where this sleeping one isn't where it's supposed to be?
Yeah, I mean, we always know that there has to be a ladybug in, like, this position that I'm circling right now. And choice number E, it just doesn't have conspicuously missing ladybug right there. So it can't be E.
I see.
Yeah. Where do you suppose we go after this, Leo?
Well, maybe we should ask the chat. I wonder if the chat has any good ideas for how we could eliminate some more answers.
Yeah.
And not just giving the correct answer, but how can we prove that it's the correct answer? Would be even more useful.
Any thoughts? Any thoughts? Well, let's think of another way we can eliminate one. Let's see. They can move up, down, right, or left, but are not allowed to go back to the cell they just came from. So, if any of these ladybugs were just moved back to one of the cells they just were at, that wouldn't be allowed.
Ooh, I see something else in the chat. I see people are pointing out option choice C. They've said that it can't move diagonally. And I think they're referring to this ladybug that I'm circling in yellow, right here. And in C, there's nothing in any of the adjacent areas. Like the closest ladybug is this one up here. So this just doesn't make logical sense. That means it can't be answer choice C. I bet there's some other ways we can eliminate like this. And how about D? For answer choice D, we got this like purple one down here, but I don't think any of the ladybugs in area D could look like this. What do you think? Or this one couldn't have gone to any of the places that we can see in D. Like they're all too far away.
Oh, yes. Because all these spaces are empty. And so that must mean that this ladybug just disappeared, and it clearly can't be that. So
Right, yeah.
yeah. And now we are just left with A and B. These seem like a tough one to eliminate.
Right.
But I think we can use the one piece of information that we still haven't used yet, which is that the ladybugs are not allowed to go back to the cell they just came from. So let's consider this ladybug. That I shouldn't repeat colors. Let me use orange this time. This ladybug that is orange over here. So this ladybug, if we go back to the third whistle, must have been this ladybug. After all, it's the only ladybug that's adjacent to this space right here. And so the orange ladybug, I'm just gonna label them too. And well, I mean, for the second whistle, that orange ladybug, it's here in the third whistle. There's only one spot adjacent there. So it must have been this ladybug. And remember, the ladybugs are not allowed to go back to the cell they just came from. And this is an example of that. And so, therefore, it cannot be B either. What do you think, Leo?
Yeah, I was thinking the same thing. And I think the chat noticed this as well. Okay, so we can eliminate B, and so the answer's got to be A. Well, just to make sure we didn't mess things up, I'll briefly draw out what it must have been for A. So this same sleeping ladybug stays sleeping. This ladybug here in blue is going to move one over to the left. So that's where this one came from. There's going to be one in this orange color, and it's going to go up because last time it can't go back down because that's where it was before, but it can go up again. That's allowed. And one more ladybug. This yellow one towards the bottom must have gone up, and that's allowed because it came from the right previously. So looks good to me. I think the answer is A, so we should check the answer.
I think so. Yeah, we should make the grand reveal, to which the chat has already been saying. And would you look at that? It's A. You all got it. Very well done. I think we're ready to move on to the next problem.
Yes. And words of wisdom from Anna in the chat. Checking your answer is always good if you have time. So do remember that.
Seconded by Rat Chile. As everyone loves Rat Chile.
Yeah.
I can read this one. You can take a break after reading that super long one.
Okay, thank you.
Louise places 3 rectangular pictures in the way shown. What is the value of X? Wow. This seems like a classic angle-chasing geometry problem. Where do you reckon we should start with this, Leo?
I think we should do some angle chasing. Like, we have this angle, and it's a little hard to see on my screen, so let me see.
Mine is very blurry too. If I put my hair behind it, it looks clearer.
Here, I'll enlarge the image a little bit.
Yeah. So that's a good idea. Let me do that as well. Actually, I think I can let me see. This makes it larger.
Yeah, I got a larger image. There you go.
Okay. Yes.
So we can see this angle right here is 62, and my question for the chat is, what is this yellow angle?
Yeah.
And I think we know that these picture frames. We got Rat Chile and his friend over here. I think these picture frames have right angles. Is that fair to assume?
Yeah. I mean, it says these are three rectangular pictures, and the property of rectangles is that all four of their angles are 90-degree right angles. And so, this is 90 degrees.
Okay, I'm seeing a lot of people saying 28. And Joe, do you think that makes sense? Where would they have gotten this 28?
Yeah, I think this makes sense because a straight line is this angle is 180 degrees. And so, since this picture frame right here is straight, it's not like curved or anything, we know that 62 degrees, the right angle from this picture frame of Rat Chile and his friend, and our mystery angle, we'll call it x, must add up to 180. And so we have 62 plus 90 plus x is equal to 180. And as the chat has very clearly already observed, 180 minus 90 minus it's disappeared. But 180 minus 90 minus 62 is equal to x, which is equal to 28.
Okay, let's fill that in the diagram.
Yes.
Okay, what can we do next? I see one other place we can do this, and it's towards the top of the diagram. Somewhere around here.
Oh, we've already used the variable x up there.
Oh, oops, that was an oversight on my part, but please believe me, that was a different x. That was
We'll call it it's fine. Yes.
It's a different x. It's a x's cousin.
Yes.
Or maybe x junior.
Yes, x junior. Okay. Let's see. So we're trying to find this blue angle right here in terms of x, I presume?
Yeah, that makes sense.
Yeah. And so blue x is this angle all the way up here. And so we're trying to find what this blue angle is. The one that, with x, makes a straight line with this picture frame, also with another right angle over there. Ooh, I see someone saying, same thing, it's 90 minus x. What do you think of that, Leo?
I like this reasoning because, and I'll write out an equation, of course. 180 equals x plus 90 plus, and then I'll have to come up with another variable name. Say it's y, just for simplicity. We have this equation, and rearranging would give y equals 90 minus x. So 90 minus x makes sense.
Wow. I remember an important theorem from geometry, which is that the internal angles of a quadrilateral have to add up to 360, because you can always divide a quadrilateral into two triangles, and we know that the angles of a triangle must always add up to 180. So let me get a new color so I'm not repeating colors. Let's see. We have this quadrilateral over here. We have a 28, a 42, and a 90 minus x. And also this angle over here that I've labeled in purple. I should not be labeling so many things in purple, actually. Let me label it in green instead. Ooh, yes, new color. Now this is why they pay me the big bucks, I just have so many colors. So, what do all of you think this green angle should be? Yeah. It might be helpful to remember that a full turn is 360 degrees. And of course, this is the right angle. This green angle I've labeled right here, which, yes.
Seeing some good ideas. I'm seeing a lot of people saying 270. And yeah, that makes sense because it's 360, which is all the degrees around a point, minus 90, because we have a right-angled picture frame with Rat Chile's ship on it. And so we've got 270. So now we have all the interior angles of this quadrilateral, and we know what they add up to. So now I think we can figure out what x is, right?
Yeah.
Let's
That
add
sounds
them
like
up.
a solid plan.
Okay, 28 plus 42 plus 270 plus 90 minus x equals 360. Okay, and let's solve. So we will now need to add up, well, we can add up 270 plus 90 and cancel that with 360 because they're the same. So, and I think we should move this x to the other side because we're like by adding x to both sides. So now you've just got x equals 28 plus 42.
Yeah. And so 28 plus 42. Oh, I see someone's already said it in the chat. Oh, you guys are always ahead of us. You guys are smart. You guys are smart. You guys are ahead of the game. You already have x equals 70.
Okay, let's see if that's an answer choice. If it's not, I think something went wrong.
Oh, hey, it's right here. Yeah.
Brilliant. It's answer choice B. Okay, should we look at the answer?
I think we should. I have pretty high faith in the chat. I mean, they've been right like every time so far. Okay.
All right, yeah, there it is. Okay, chat keeps up their perfect streak, and we can move on to the next problem. Okay, my voice is replenished, so I can read this one. You can rest your voice a little bit. Okay. Julia wants to fill in each box with a different prime number less than 20 so that the value of a is an integer. What is the maximum value of a?
Well, I mean, if we want the biggest value of a, we want all these values up here to be... Ooh, let me just see if I can draw this arrow better. We want all the values up here to be big, and this value down here, we want it to be small. So let's list... I mean, there aren't that many prime numbers less than 20. I think we can just list out most of them.
Yeah, I see a good suggestion from the chat saying exactly that. Okay, so we've got 2, one of the favorites, one of the goats, you might even say.
Classics.
3, 5, 7, okay, 11, 13, 17, 19. Boom. Okay, and then how many boxes are there? I mean, we've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay.
Yeah.
8 boxes and 8 numbers. Okay, so we're going to be using all of our numbers.
Well, my first instinct is to see, well, I mean, we want the smallest possible number in the denominator, and out of all these numbers, 2 is the smallest one. So it would be great if we could put 2 in this small box, but I think there might be a problem with that. What do you think?
Yeah. Well, I can already envision a problem without even calculating what it is. Because if we're adding up 7 odd numbers, we're going to get an odd number. And then dividing by 2 is not going to yield an integer.
Yeah.
So we know we can't put 2 on the bottom. And I wonder if we could put 3 on the bottom, because that's our next best option, isn't it?
Yeah. And it's not like instantly eliminated like 2 is, so I think we can go through with that.
Sure,
Yeah.
Let's give it a try.
And, well, I mean, we have 7 numbers left out of these 8 primes, and all 7 of them have to go up here. So let's try adding all of these other ones and see what it adds up to. 2 plus 5 plus 7 plus 11, 13, 17, 19. Well, I think we just have to go through and do the legwork in adding this. Now, a nice little trick that I sometimes use when adding is to just add pairs of numbers that add up very nicely. For example, 7 plus 13 that adds up to 20. And so this makes life easier instead of adding them up one by one, because then you have to carry stuff over and all that. Sometimes it gets, unnecessarily complicated. We know 7 plus 13 is 20, 11 plus 19 is 30. And so we can simplify this to 2 plus 5 plus 20 plus 17 plus 30. And while we can combine these, this makes 7. And we have, and 20 and 30, they just make 50. So we're adding up very nice numbers. So this makes life easier. You don't have to spend so much time on like the carrying and the calculation and all that. It's a nice time save for all you speedrunning folks out there. So you have 7 plus 17 plus 50. 7 plus 17, that's 24. And 20 plus 30 is 50. And so our top number becomes 74. Ooh. Do you guys think 74 is divisible? Do you think we can get an integer out of that? We have 74 on the top and 3 on the bottom.
I think the chat's already moved on without us, and they determined that this is not going to work for us. So maybe there's a more efficient way we can do this. Like, without summing up everything, or I guess rather the best way would be to sum up everything.
Yeah.
So we had 74, right?
Mm-hmm. Yeah.
And that was not including 3. So if we do include 3, the total sum will be 77. So if we were to try 5, for example, we would have 77 minus 5 over 5. And what's that? It's 72 over 5, which doesn't work for our purposes. So what we need is something small that when subtracted from 77 is a multiple of that number.
Yeah. Ooh, someone says that 7 is working for them. I think we should try it out.
Because after ruling out 2, 3, and 5, 7 would be our best option. So if 7 works, that's the correct answer to the question.
Let's see.
Okay. 77 minus 7 over 7 is 70 over 7, which equals 10. So our answer is 7, correct? No? That's not an option?
Yeah.
Huh.
Let's see. Let's reread the problem, In competitions, it's important to know exactly what it's asking for. And actually is asking for the maximum value of A.
Ah, I see. So our answer would then be 10, which is an option choice. Option choice C.
Yeah. I feel pretty confident in this answer. And the chat is, I see at least 30 C's in that one alone. So they seem pretty confident. And I'm pretty confident in the chat. What do you think, Leo?
Yeah. I trust in the chat. Okay, let's see if we're right.
Hey.
Voila.
Chat is proven right once again. You guys are on a huge win streak. Let's see if you can keep it up with our next problem. Ooh, another geometry problem. In the rectangle ABCD, the points E and F are marked on side DC as shown, so that angle EBA equals angle DFA equals 45 degrees, and AB plus EF is 20 centimeters. What is the length of BC? Oh, that's a lot of words. I think we should convert these words into some math and diagram stuff. What do you think, Leo?
Okay, good idea. So let's say the distance, maybe the distance between E and F is, how about X? Does that make sense?
Yeah. We don't know it yet, but I think we can use some information to try and find it out. So it's good to set a variable for now.
Right. So then the distance between A and B would be 20 minus X.
Oops.
And I think now we've pretty much written down everything there is, except a lot of angles here are going to be 45 degrees. So this angle, this one, this one, this this one. A lot of 45-degree angles.
Hold your horses for a moment. It just says that DFA and EBA are 45 degrees.
Oh, oops, I jumped the gun. DFA and EBA. Okay. Well, I think it would not be too much of a challenge to show that the other ones are. So we have DA and B is a right angle because it's in a rectangle, which means that FAB is 45 degrees. And similar thing for CBE. And then by matching interior, alternate interior, what are they called?
I mean, we have this is a right angle too. So we know that, I can't point on your screen. This angle, this and this angle have to add up to 180. So that one also has to be 45.
Yeah.
Yeah. There's a lot of 45-degree angles here. So you guys can use your imaginations for the other ones. Well, let's see. So, I think I read somewhere that there's something special about these triangles that have 45-degree and 45, 45, 90 triangles. I can't seem to remember what it is.
Yeah, maybe some ideas from the chat. Oh, wait, I see it from Audrey. They are isosceles. Yes, very good. Okay, if we have that they are isosceles, what can we... All right, and they're also a special triangle. So what's the side length ratio? Do you remember that one now, Joe?
Yeah. I mean, 45, 45, 90 triangles. Wow. Even if I don't remember it off the top of my head, I can still try to find out the ratios. I mean, we know these are both the same. So let's say this is we've already used x, let's use a. This is a. And by the Pythagorean theorem, as we all know, a squared plus b squared is equal to c squared. I mean, both a and b are just a here. And so we have 2a squared is equal to c squared, and which gives us c is equal to a times the square root of 2, because we just take the square root of both sides here. And so that's our ratio here. I think we can fill out some information with this. Can get some of the side lengths. Let's label this intersection point right here. Let's label it what have we not used that? M. Let's label this intersection point M. Sure. So, let's see. What do you think EM should be in terms of x?
EM would be x over root 2. So that when it's... x over root 2. So that when it's multiplied by root 2, then you just get back to x for the hypotenuse EF. And I'm going to label it on the other side, because remember, this is isosceles, so it doesn't really matter.
Yes. Because EM...
Because both are equal.
Yes. All of them are the same. And so we can label this x over... I'm going to rationalize the denominator, which can be helpful in some points, but most of the time it's just a habit that varies from person to person. It is sometimes helpful, though. And let's see. BM. I think we can also figure out some relation between BM and AB, just the same as EF and EM. What does chat think? What does chat think? Let's ask chat. I mean, chat has not been wrong a single time so far.
Yeah.
So,
I think we can send this one to chat. Let's get some ideas.
Yeah, let's get some ideas in chat. Ooh. Is my chat working? Yes. Our angles. Making these triangles right triangles. That is true. Yes, chat has been always right so far. Yes. I mean, I see an idea. I see ideas in chat. Right now we're asking, what do you have is, let's see, where is it? MB or MA? Yes. It's okay if you guys are stuck. Just remember that, well, I mean, I think, Leo, what do you think?
Well, I think we can it's kind of the same triangle. It looks bigger, but it's the same idea going on here. It's a 45, 45, 90 triangle, and we have the hypotenuse. So that means we can label one of these shorter legs as 20 minus x divided by root 2. I'll do that in a different color just so you guys can see what happened there. But it should be 20 minus x over root 2. And I guess I'll, just for you, Joe, I will rationalize the denominator.
Thank you. It's all I've ever wanted, you know. All I want for Christmas is a rationalized denominator. Yes. I hope some of you got that reference in the chat. Okay. Well, let's see. It's asked for the length of BC. And, so how can we relate the length of BC to these? Well, I mean, look over here. We have this right angle in purple. We have this 45-degree angle that I've already labeled in orange, but I'm going to circle in purple. So, you know, it's extra important. You know, this has 2 colors. You know, the more colors, the better. And this is also a 45-degree angle because ABC is a right angle. And so we know we can apply this same relation to ECB, the same relation that we've used many times over here that I'm circling in orange. Yeah. What do you think we should do next, Leo?
Oh yeah, this is a good idea. So we have the length EM, we have the length MB, so we have the length EB, and now we've just got another one of these 45, 45, 90 triangles with our leg as BC.
Yeah. So let's start by simplifying the EM plus MB, because I think we want it to be one number before we do all this simplifying. Yeah.
Right.
So in chat, what do you think EB should be? Yeah. Put your ideas in the chat.
What is the length EB? And you're free to not rationalize your denominator, but Joe might be disappointed.
Yes, I will be a little bit sad if you guys don't rationalize the denominator. It's a habit I have, you know. Old habits die hard. A lot of people say that, you know. And you know, rationalizing the denominator, it's often helpful. It's a decent habit to have. Yeah. So put your ideas in the chat. What do you think EB, length EB should be? Remember that EM is equal to x times root 2 over 2, or x over root 2. And MB is 20 minus x times root 2 over 2. Oh, I see a lot of people putting D in chat.
Yeah.
Yeah.
But not a lot of distances from E to B.
Yes. Let's see. Yeah, a lot of people are saying answer choice D. I think they're jumping a bit ahead of it.
I see one from Gotham. Okay. I see 10 square root 2. And that's basically what I had. I actually had it in slightly different form. So if we have x over root 2, and I'm going to revert back to the non-rationalized version just for addition here. I'm sorry. And we have 20 minus x over root 2. Well, we have a common denominator now. So it would be, and we can cancel, or it would be x plus 20 minus x over root 2, or just 20 over root 2. Does that seem right to you? And then we could re-rationalize it, of course. So that would be 10 square root 2.
Yeah. And so now we have the length of EB. I'll just say EB is equal to 10 square root 2. And we've gotten all this information so far just by repeatedly using this relationship right here with the 45, 45, 90 triangles. Those are really the crux of this problem. And now we're about to use it one more time to find the length of BC. Because if EB is 10 times the square root of 2, then what should BC be? Given that we know it's a 45, 45, 90 triangle. Yeah. Yeah, I'm seeing a lot of D's in the chat, but I actually don't have my answer choices right here. So I'm gonna need some of you to put the answer, the number. Yes, I see Yuri has said 10, and I think that checks out. What do you think, Leo?
Yeah, I'm seeing more and more tens in the chat. This is great. I also got 10, so I'm confident that the answer should be 10. And before we look at the answer, I'd like to say I think this is a pretty cool result because we have no idea what x is still. Like the problem never let us figure out what x is. I think it's impossible to know what x is. It doesn't matter though, right? Because we just needed to figure out BC to solve the problem, and I don't think x. I think the distance, like how far up from this point, it doesn't matter. All that matters is that like the sum of a and b and e and f is 20. So therefore we have BC equals 10.
Yeah. Well said, Leo. Well said. Yeah, because in competition math, sometimes you can find the answer without knowing every single little detail of the problem, and that's an important detail. That's an important detail of competition math. It's something good to remember. Yeah. So yeah, I think it should be answer D. I mean, I trust the chat and I trust the math we've done.
Yes, fingers crossed. Let's take a look.
Hey! Hey! Oh, I can't. Like, my pen doesn't go into your screen, unfortunately. But we both have D, 10 centimeters. Yes, all I want for Christmas is rationalized denominators. Doesn't have the same ring to it as Christmas, unfortunately. Let's move on to the next problem. Yeah. Chat is.
Okay. Oh, and I quite like this problem. Okay. I think it's my turn to read. Is that right?
I don't remember clearly, but you can have the honors this time. You can have the honors this time.
Okay. Peter drew a quarter circle with center at each corner of a flag with dimensions 12 centimeters by 9 centimeters and colored the region formed as shown. What is the length indicated by the question mark? And that's towards the bottom. I'm now going to enlarge this on my screen so you guys can see it a little better.
I think I will do the same. Let's see.
Okay, there's a perfect opening here for my head to sit in with the problem and the answer choices. This is great.
Let's see. Wow. Okay.
Any ideas from the chat for where to start? There's a lot of places we could start and still get the correct answer here. And
yes. Someone is saying, curvy things. Yeah, curves make some problems harder because the lines are no longer straight.
Yes, but I think it makes this problem easier.
Yeah. Yeah. Ideas on how to start off with this problem in the chat.
I'm seeing start with the 9 radius. Could you put the radius of the biggest circle as x? Ooh, okay. Now, that's a good idea. So, yeah, let's make the radius of this large circle x. And so this circle this quarter of a circle right here, its radius will be x.
This x right here.
And notice that x is not equal to 9 because there's this little rat chile nibble in the bottom left. It doesn't go all the way down. The length of x is a little bit less than 9.
Yeah. Well, I mean, there's an important property of circles that I seem to remember, which is that for a circle, all the points on the circle are an equal distance away from the center, which is the radius distance. So if I have a circle over here, and this is the center of the circle, it's actually a pretty good circle, one of the better circles I've drawn, but all these radiuses, or radii, I think is the technical term, all of these are the same length, which is a very useful property of circles. And so I think that gives us some more information on our graph. What do you think, Leo?
Yeah, and I think I may have skipped ahead a little bit and already labeled it. But what Joe is trying to hint at is that from this center, the distance here all the way to here and here down to here is going to be the same. It's going to be this radius x. So we can label that's x, and we can label that this is x as well.
Yeah.
So then that begs the question, what is this length right here? And this one shouldn't be too hard to find. I'd like the chat to give us the answer to this one.
Yeah. Yeah. What is the blue length labeled here? And preferably give us an answer in terms of x. Yeah.
Oh, wow, an explosion of answers. Okay, so 12 minus x. That's what I was looking for. Because it's what you add to x to get 12.
Yeah. And since we don't know what x is so far, our best bet is just to represent it in terms of x, you know? Get as much value as you can from the variable, you know? And we can apply the same logic with this circle, all the radiuses. I'm gonna say radiuses because I prefer it. All the radiuses are the same length. So since we know this is a quarter circle, we know that this other blue length is also 12 minus x. Well, let's move around this rectangle and try to label all of these little lengths over here.
All right, good idea.
Let's say this one is in red. Oh, you can't see the red very well on here, but it's fine.
I was
you can
thinking
count
red
it.
also. Yeah.
Red. Okay. Let's see. Does the chat have any ideas on how we can find the red length right here? It's a bit clearer on Leo's screen. Look over there if you don't know which side I'm pointing to. Yeah. I think we'll also need to find this one, maybe in terms of x. Yeah. Now put your ideas in the chat. What is the red? Oh, you can't see my finger if I put it there. What is red? Ooh, I think I saw something in the chat, but it like scrolled away really fast. Oh, there it is again. Yes. 9 minus in parentheses 12 minus x.
Yes, fantastic. Because the total length is 9, and if we want to get this red part, we subtract off the blue part, which is 12 minus x. So 9 minus, in parentheses, 12 minus x, which some people have conveniently put as x plus 3. Wait.
Oh, x minus
3.
3.
I think it should be x minus 3.
Yeah, I think it's x minus 3. The plus and minus keys are very close on the computer.
It must have been a typo. So I think so we should fill in x plus 3. Or x minus 3, I'm getting confused.
X minus 3. Drawing typo.
Yeah. The minus and plus look really similar.
Yeah. So let's finish off our corners. We only got one corner left. Now it's like 4 corners.
Yes.
I think it's a board game, but I could be mistaken.
It's also a place in the United States.
Oh, yes. It's between like New Mexico and Colorado and Arizona and
Utah.
The other one. Yes. We're getting off topic. Sorry. Yes. So I try to find the length of this little yellow rat chile bite right here. Yeah. You know, that's why it's yellow. It's because rat chile likes to eat cheese, and cheese is yellow. Rat chile. You might have seen rat chile in the chat a few times. You know, rat chile is a very prolific chatter. Yeah. But I'm seeing some other prolific chatters in here with 9 minus x yes.
Brilliant. Yeah.
Because the yellow and the green add up to 9. So since the green is equal to x, the yellow must be 9 minus x. Wow, this is a lot of information you have here. But how does it help us find this mystery length? How do you think we can use this information, Leo?
Well, I bet the chat can help us figure out this one. We've got this bottom length, and we know it adds up to 12 totally. And we've got this question mark, and we've got these other 2 lengths that comprise the total of 12. So how can we figure out this question mark length?
Yeah. Oh, wait, I saw someone put it in the chat. Like whoever put it in the chat, I'm sorry, I might have missed your name. But oh yeah, loads of other people are putting it in the chat too. But yes, we can find this mystery length because mystery plus the yellow plus the red is equal to 12. Which means that, let me just write the base version first, plus the mist. Ooh, I should change colors for every single one so I can be like a fancy schmancy pants.
Hey, you could use purple for the bottom one. That's what I recommend.
Ah, yes, that's a better idea. Yes. Yes. I'm being fancy right now with all these different colors. But yes, we have the yellow plus the purple plus the red is equal to 12. And so when we simplify this, hmm, what do you think we should do next, Leo? I think
I'm seeing a lot of people saying, "Oh, wait, you already got the?" Oh, okay. I
oh,
think we should cancel the value of x because there's a minus x and a plus x. So, yeah, let's do that. We've got 9 plus question mark. I'm reading off Joe's screen. 9 plus question mark minus 3 equals 12. And then we can also calculate 9 minus 3, which equals 6. So we have 6 plus question mark equals 12. Now, we could keep doing algebra from here, but I think it's pretty easy to see, just from looking at this, that the question mark has to be 6.
hmm, yeah, I think that makes sense. Yeah, I see a lot of sixes in the chat, and a lot of six factorials too.
Be careful. 6, yeah. We don't want, the answer will not be 720 right now. So we're definitely not looking for 720. That would be quite a surprise.
Yes. Let's circle B. Yeah, and I think that's the answer. I mean, a lot of people are putting six in the chat. A lot of people I think were putting B earlier too. And chat is like absolutely goated. They were cooking this session, and I think they're about to cook again.
Okay, let's see the answer. Again, it's 6. Okay, great work. Chat is on fire.
Yes. Yes. Let's see. Um, ooh, I think it is.
I think
It
it's
is.
time.
Yes. I think we might be running a little overtime. So thank you to everyone who came today. I hope you all had fun. I hope you all enjoyed your huge win streak. Um, but yeah, we're very glad to have hosted this. This was a load of fun. I hope you all had fun too. Yeah. Any closing words, Leo?
Uh, no. I guess thank you all for coming, and I had fun as well.
Yeah.
Okay, goodbye.
Bye. Remember, math is cool.